Okay, good evening. Welcome to
Calculus 16.
Calculus 16. So today we're going to be talking about derivatives of exponential functions, like 2 to the x, or 3 to the x, or 1/2 to the x, things like that. Okay. But I'll stick on sort of this general form of a to the x, where a is greater than 0.
Alright.
Do you know why I have to stick to the thing being greater than 0?
Because it can get confusing when a is less than 0.
Yeah, it might not even be defined. At least not for real numbers. So we're going to have an exponential curve, and if a is bigger than 1, it's going to look like this. And we're going to try to find the derivative. Okay. How do you think we'll do that at some point, x?
Well, we might be able to use logarithms. Maybe to get the x out somehow and find the derivative that way. Maybe get this into like a slightly different form.
Yeah, it's an interesting idea of using logarithms, which are inverses of exponential functions. The trouble is then we're stuck trying to find derivatives of logarithms.
Which I also don't know how to do.
Which we also don't know how to do. But it's actually a good idea to think that the derivatives of exponential functions are connected to derivatives of logarithms. But there's another approach we can use, a different approach to find the derivative here.
Well, maybe you could approximate this curve as a quadratic or fourth degree polynomial.
Okay, yeah, maybe we could find approximations, but I actually want to find the derivative exactly.
Well, we could try we could use our old limit definition.
Yeah, that's exactly what we want to do. We want to say this is going to be the if f of x equals a to the x, then the f prime of x equals the limit as h goes to 0 of, do you remember what it is? We haven't talked about this in a while.
F of x plus h minus f of x, or minus f of h. No, minus f of x all over h.
Okay. So that's going to be a to the x plus h minus a to the x all over h. Can I simplify that at all?
You could take out an a to the x, you could factor.
Of a to the x times, which has no dependence on h. By the way, let's just check we're on camera here. A to the h minus 1 over h. Which is interesting. For all these exponential functions, they all simplify down to one very simple expression. The limit as h goes to 0. So the derivative at x is a to the x times whatever this is, a to the h minus 1 over h. And this, by the way, also happens to be the derivative of the original exponential function at a specific value of what value is this?
X equals 0?
Yeah, x equals 0. So the interesting thing about all exponential functions is at any point x, the derivative is just that value, a to the x, multiplied by the derivative at 0. It's kind of a surprise. But we don't know what this limit is. So it all boils down to calculating this limit, h goes to 0, of a to the x minus 1, h over h, for values of a. For some, yeah, that's what we got to do. So what we're going to do is we're going to go to Mathematica to play around with that.
All right.